The history, current status, challenges, and future development of satellite internet services, an analysis of technology, market, and applications. Introduction. Satellite internet services have evolved significantly since their inception, driven by technological advancements, changing market dynamics, and evolving regulatory frameworks. This report provides a comprehensive analysis of the history, current status, challenges, and future development of satellite internet services, emphasizing technological innovations, market trends, and various applications. History of satellite internet services. The journey of satellite communications began with the launch of Sputnik by the Soviet Union in 1957, marking the dawn of the space age. The first commercial communications satellite, Telstar, was launched in 1962, paving the way for satellite broadcasting. The introduction of geostationary satellites in the 1960s allowed for constant coverage over specific areas, which was a critical development for the subsequent growth of satellite internet services. In the 1990s, the concept of providing internet services via satellite began to gain traction, with companies like Hughes Network Systems and Teledesic attempting to offer broadband connectivity. Early satellite internet services were limited by high latency and low bandwidth, primarily due to reliance on geostationary satellites positioned 35,786 kilometers above the Earth. The landscape began to shift dramatically in the 2010s with the advent of low Earth orbit (LEO) satellite systems. Companies like SpaceX, through its Starlink project, and OneWeb started launching large constellations of satellites in LEO, significantly reducing latency and increasing bandwidth capabilities. This marked a new era for satellite internet services, enabling global coverage and improved connectivity, especially in underserved regions. Current status. As of 2023, satellite internet services are experiencing a transformative phase. The emergence of megaconstellations has revolutionized the market, with SpaceX's Starlink leading the way. Starlink aims to provide high-speed internet access across the globe, focusing on rural and remote areas where traditional internet infrastructure is lacking. Other players such as Amazon's Project Kuiper and OneWeb are also competing to establish significant market presence. The current status of satellite internet services can be characterized by 1. Market expansion. The global satellite internet market is expected to grow significantly, driven by increasing demand for connectivity in remote and underserved areas. 2. Technological advancements. The deployment of LEO satellites has reduced latency to levels comparable to terrestrial broadband. The technology includes advanced phased array antennas, improved encoding techniques, and efficient routing algorithms. 3. Diverse applications. Satellite internet services are being utilized across various sectors, including telemedicine, agriculture, education, and emergency response. The ability to provide connectivity in disaster-stricken or remote areas is increasingly recognized as a vital service. 4. Competitive landscape. The market is becoming increasingly competitive, with established players facing challenges from new entrants and alternative technologies. Traditional broadband providers are also evaluating partnerships with satellite companies to expand their service offerings. Challenges facing satellite internet services. Despite the progress made, the satellite internet sector faces several challenges that could impact its future growth. 1. Orbital debris. The increasing number of satellites in orbit raises concerns about orbital debris. Collisions and the resultant debris can pose risks to both existing and future satellite operations. 2. Regulatory issues. The satellite internet industry must navigate complex regulatory frameworks, including frequency allocation and spectrum management. As the number of satellite systems increases, regulatory bodies need to adapt to ensure efficient use of space. 3. Cost of deployment. While advancements in technology have reduced launch costs, the overall expense of deploying and maintaining satellite networks remains high. This can limit the ability of smaller companies to enter the market. For market competition, the rise of alternative internet technologies such as fiber optics and 5G poses a significant threat to satellite internet services. In regions where terrestrial options are available, satellite services may struggle to compete on price and performance. 5. User terminal costs. The cost and complexity of user terminal equipment can hinder widespread adoption. Continued efforts to reduce costs and improve ease of use are essential for expanding the customer base. Future development of satellite internet services. The future of satellite internet services appears promising, driven by ongoing technological advancements and growing global demand for connectivity. Key trends and developments expected in the coming years include: 1. Technological innovations. The next generation of satellites is anticipated to feature enhanced capabilities, including improved power systems, advanced propulsion technologies, and more efficient communication protocols. 2. Integration with terrestrial networks. The convergence of satellite and terrestrial technologies will create new opportunities for hybrid connectivity solutions. This integration can enhance service reliability and coverage, particularly in rural areas. 3. New applications. As satellite internet services become more accessible, new applications will emerge across various sectors. Areas such as IoT, smart agriculture, and remote monitoring will benefit from improved connectivity. 4. Increased investment. The demand for reliable global connectivity will drive further investments in satellite communications. Governments, private companies, and international collaborations may play a significant role in funding future projects. 5. Focus on sustainability. Addressing concerns about orbital debris and environmental impact will be crucial for the long-term viability of satellite internet services. Companies may need to prioritize sustainable practices in satellite design and deployment. Conclusion: the history, current status, challenges, and future development of satellite internet services illustrate a dynamic landscape influenced by technological advances and market demands. While the industry faces significant challenges, particularly regarding orbital debris and regulatory hurdles, the potential for growth remains substantial. The integration of satellite and terrestrial systems, coupled with innovations in technology, will likely shape the future of satellite internet services, making them an essential component of global connectivity in an increasingly digital world. As satellite internet services continue to evolve, their role in bridging the digital divide and providing critical connectivity to underserved areas will be paramount, ensuring that the benefits of the internet are accessible to all. The history, current status, challenges, and future development of satellite internet services encompass a wide array of technological advancements, market dynamics, and unique challenges that shape the industry. Below, we delve into these aspects without summarizing the content, while also highlighting counterintuitive insights. History. The inception of satellite communications can be traced back to the launch of Sputnik in 1957, marking humanity's first step into the realm of space-based technology. The 1960s saw the introduction of geostationary satellites, which revolutionized communication by allowing for constant coverage over specific regions. This development laid the groundwork for what would eventually evolve into satellite internet services. Counterintuitively, while satellite technology has progressed significantly, its adoption has often lagged behind terrestrial communication advancements. For decades, satellite communications were seen as a supplementary service to terrestrial networks, often criticized for high latency and cost. This perception has shifted only recently with the advent of low Earth orbit LEO satellites, which promise lower latency comparable to that of terrestrial broadband. Current status. Today, satellite internet services are experiencing a renaissance, largely driven by innovations from companies like SpaceX and OneWeb. These enterprises aim to establish megaconstellations of LEO satellites, which effectively reduce latency issues that have historically plagued satellite internet. The current market landscape indicates a shift towards global broadband coverage, particularly in rural and underserved regions where traditional broadband infrastructure remains scarce. A counterintuitive point is that despite the rapid expansion of satellite internet services, they still face stiff competition from terrestrial broadband options, which are often perceived as more reliable and cheaper. This competition highlights that while satellite internet is critical for certain demographics, it is not universally adopted due to perceived drawbacks such as cost and service quality. Challenges. The satellite internet industry faces a multitude of challenges that may not be immediately apparent. Orbital debris is a pressing concern, as the rapid increase in satellite launches raises the risk of collisions. This could not only threaten existing satellites but also complicate future launches and operations. Regulatory hurdles further exacerbate this issue, with existing frameworks struggling to keep pace with the burgeoning number of satellite systems vying for frequency allocation and spectrum management. Moreover, the high costs associated with launching and maintaining satellite networks present a significant barrier to entry for many potential players in the market. While technological advancements have reduced some costs, the initial investment remains substantial, leading to a concentration of market power among a few key players. Counterintuitively, the growth of satellite internet services may increase the complexity of regulatory compliance rather than simplify it. As more companies enter the market, the need for coordination and regulation becomes more critical, potentially stalling progress as companies navigate a complicated landscape of policies and international agreements. Future development. Looking ahead, the future of satellite internet services appears promising, driven by continuous technological innovations. Enhanced satellite designs, improved user terminal technologies, and advanced encoding methods are expected to further enhance service quality and accessibility. The anticipated convergence of satellite and terrestrial systems is likely to foster innovative applications across various sectors, including telemedicine, IoT, and emergency communications. Interestingly, while the growth of satellite internet services is often framed as a solution for connectivity gaps, there are concerns regarding the environmental impact of increased satellite launches. The challenge lies in balancing the demand for global connectivity with the need to address issues of orbital sustainability and space debris. Furthermore, the integration of satellite and terrestrial technologies presents a counterintuitive challenge as the two systems converge. The complexity of managing and optimizing these hybrid networks increases. This could lead to unforeseen complications in service delivery and regulatory compliance, as companies will need to navigate the intricacies of operating across both platforms. Conclusion. The trajectory of satellite internet services is characterized by a complex interplay of technological advancements, market demands, and regulatory challenges. The growth of LEO satellite constellations represents a significant leap forward, yet the sector must navigate a myriad of obstacles, including orbital debris and regulatory hurdles. As we look to the future, the potential for innovative applications and enhanced global connectivity is immense, but it is equally crucial to consider the environmental and regulatory implications of this growth. The satellite internet landscape will continue to evolve, with its success hinging on the balance of technological innovation and responsible management of space resources. Important content overlooked in Satellite Internet Services Report. 1. Digital processing technologies. The report emphasizes advancements in digital processing technologies as pivotal in enhancing satellite communications. However, it may be overlooked that these advancements are not merely incremental but are fundamentally altering the architecture of satellite systems. The significance lies in the fact that satellites are evolving into sophisticated digital processors that can perform complex computations and data management tasks on board, which reduces the need for ground-based processing and accelerates data delivery. This shift enables new capabilities such as real-time analytics and adaptive bandwidth allocation, which can significantly enhance user experience and service reliability. 2. Orbital debris concerns. While the report mentions orbital debris as a challenge, it does not delve into the implications of this issue on the sustainability of satellite internet services. The risk posed by debris is not just a technical challenge, it represents a critical threat to the long-term viability of satellite operations. Each new satellite launch increases the potential for collisions, which can create more debris, leading to a vicious cycle that could jeopardize the entire satellite ecosystem. The significance of this issue is profound as it raises questions about the future of space traffic management and the need for international cooperation in creating effective regulatory frameworks to mitigate debris-related risks. 3. Regulatory hurdles and spectrum management. The report touches on regulatory hurdles but may overlook the intricacies involved in spectrum management as satellite networks proliferate. The competition for spectrum is intensifying, and the existing frameworks may not adequately accommodate the rapid deployment of megaconstellations. This can lead to conflicts between new and existing operators, resulting in service interruptions or degraded quality. Understanding the regulatory landscape is crucial for stakeholders to navigate potential legal and operational challenges, ensuring that innovations in satellite technology are not stifled by bureaucratic inefficiencies. For market dynamics and competition, while the report discusses the competitive landscape, it may not fully capture the implications of mergers and acquisitions in shaping market dynamics. The consolidation of satellite providers can lead to fewer choices for consumers and potentially higher prices. Moreover, the strategic partnerships between satellite companies and terrestrial internet providers could redefine how services are delivered, creating hybrid models that blend the strengths of both technologies. This convergence has the potential to disrupt traditional business models and necessitates adaptive strategies from existing providers to remain competitive. 5. Global connectivity and socioeconomic impacts. The report mentions the demand for connectivity in rural and underserved areas but might overlook the broader socioeconomic implications of satellite internet services. Access to reliable internet can empower communities, enhance educational opportunities, and facilitate economic development. The ability of satellite systems to provide connectivity in remote regions can bridge the digital divide, fostering inclusivity and enabling participation in the global economy. Understanding these impacts is essential for policymakers and stakeholders to prioritize investments and support initiatives that maximize the social benefits of satellite internet. 6. Technological convergence with terrestrial systems. The report highlights the convergence of satellite and terrestrial systems but does not explore how this integration can lead to innovative applications. For instance, merging satellite capabilities with 5G networks can enable seamless connectivity in urban and rural environments, enhancing communication during emergencies or natural disasters. This convergence can also facilitate the development of IoT applications that require reliable low-latency connections across vast distances. Recognizing these synergies is critical for stakeholders to harness the full potential of satellite internet services in various sectors. 7. Emerging applications and future trends. While the report mentions telemedicine and IoT as potential applications, it does not fully explore the breadth of emerging applications that satellite internet can enable. For example, advancements in satellite technology could support smart agriculture, autonomous vehicles, and disaster recovery efforts. The ability to provide real-time data and connectivity to remote locations can revolutionize industries and improve operational efficiencies. Identifying and investing in these emerging applications is crucial for driving future growth and innovation in the satellite internet sector. 8. User experience in terminal technology. The report briefly touches on improved user terminal designs but may overlook the significance of user experience in driving adoption. The success of satellite internet services hinges not just on technology but also on how accessible and user-friendly these services are. Innovations in terminal technology such as phased array antennas and self-installation kits can drastically lower the barrier to entry for consumers. By focusing on enhancing user experience, providers can expand their market reach and improve customer satisfaction, which is vital for long-term success. 9. International collaboration and standards. The report discusses regulatory changes but may not emphasize the importance of international collaboration and standardization in the satellite internet landscape. As satellite networks operate on a global scale, harmonizing regulations, frequency allocations, and operational standards across countries is essential to avoid conflicts and ensure interoperability. Collaborative efforts among nations can foster a more stable and predictable environment for satellite operations, which is critical for long-term investment and innovation in this sector. 10. Environmental impact considerations. The environmental implications of launching and operating satellite networks are not adequately addressed in the report. The carbon footprint associated with rocket launches and the potential for space pollution could become significant issues as the number of satellites increases. Stakeholders must consider sustainable practices and technologies that minimize environmental impact, such as using green propulsion systems and developing end-of-life strategies for decommissioned satellites. Acknowledging and addressing these concerns is essential for the industry's social license to operate and for meeting global sustainability goals. In conclusion, while the report provides a comprehensive overview of satellite internet services, it is crucial to explore the overlooked aspects highlighted above. Understanding these elements can inform stakeholders' strategic decisions, drive innovation, and promote sustainable practices, ultimately shaping a more resilient and inclusive satellite internet ecosystem. 1. Technological advancements in satellite communications. The evolution of satellite internet services is significantly driven by advancements in digital processing technologies. As satellites have transformed into sophisticated digital processors in space, improvements in encoding methods, user terminal designs, and overall processing power have greatly enhanced performance and capabilities. The continuous application of Moore's law in this domain suggests ongoing growth in efficiency and service quality, which is critical for meeting the increasing global demand for connectivity. 2. Global connectivity demand. The insatiable need for reliable internet access, especially in remote and underserved areas, serves as a primary catalyst for the expansion of satellite internet services. This demand underscores the importance of satellite technologies in bridging the digital divide, providing essential services such as telemedicine, education, and emergency communications where terrestrial infrastructure is lacking. 3. Industry challenges. The satellite internet sector faces significant hurdles that could impact its future growth, including the challenges of orbital debris, regulatory complexities, and the high costs associated with launching and maintaining satellite networks. The increasing congestion in orbital space due to the proliferation of satellites raises safety concerns, and the need for effective spectrum management becomes paramount as more players enter the market. Addressing these challenges is crucial for ensuring sustainable development in the sector. For integration of satellite and terrestrial technologies, the convergence of satellite and terrestrial systems is poised to create new opportunities for innovative applications across various sectors. This integration can enhance service delivery and expand the functionality of satellite systems, leading to more versatile solutions that meet diverse consumer needs. As the landscape of telecommunications evolves, leveraging both satellite and ground-based technologies will be key to driving future developments in connectivity solutions. 1. The launch of Telstar 1 1962. Telstar 1, launched by AT&T and NASA, was the first active communications satellite. This satellite revolutionized telecommunications by enabling live television broadcasts and telephone calls across the Atlantic Ocean. Its successful operation marked the beginning of satellite-based communications, setting a precedent for future advancements in satellite internet services. 2. Iridium Satellite System 1997. The Iridium project, initiated by Motorola, aimed to create a global communications network using a constellation of 66 satellites in low Earth orbit. Although faced with financial difficulties and bankruptcy shortly after its launch, Iridium eventually rebounded and provided critical communication services, including satellite phones and data services. This case highlights the challenges and potential in establishing satellite networks for global connectivity. 3. The development of Globalstar 2000. Globalstar was launched to provide satellite phone services and data communications globally. It utilized a constellation of 48 LEO satellites to deliver services focusing on remote and underserved regions. Globalstar's challenges included competition from terrestrial networks and financial instability. Yet it underscored the importance of satellite communication in providing connectivity where traditional infrastructure was lacking. Future outlook: predictions for satellite internet services. The future of satellite internet services is poised for significant transformation driven by advancements in technology, evolving market dynamics, and an increasing demand for global connectivity. Based on current trends and developments, several key predictions can be made regarding the future trajectory of satellite internet services. 1. Increased global coverage. The emergence of megaconstellations like SpaceX's Starlink and OneWeb will likely lead to enhanced global coverage, particularly in remote and underserved regions. As these companies continue to launch satellites into low Earth orbit, LEO, the ability to provide high-speed internet access to previously unconnected areas will expand, bridging the digital divide. 2. Reduced latency and improved speeds. The use of LEO satellites significantly reduces latency compared to traditional geostationary satellites. As technology advances, further enhancements in satellite design, such as improved propulsion systems and optimized orbital arrangements, will contribute to even lower latency and higher data speeds, enhancing user experiences. 3. Convergence of satellite and terrestrial networks. The integration of satellite and terrestrial networks will become more prevalent, enabling hybrid connectivity solutions. This convergence will facilitate seamless transitions between satellite and ground-based services, allowing users to maintain consistent connectivity regardless of location. Potential applications include emergency response scenarios, telemedicine, and smart city infrastructure. For regulatory and operational improvements, as the number of satellites in orbit increases, regulatory bodies will need to adapt and create frameworks to manage frequency allocation and orbital traffic. Enhanced international collaboration will likely lead to more efficient regulations, minimizing the risks associated with orbital debris and improving the sustainability of space operations. 5. Technological innovations. Ongoing advancements in satellite technology will lead to the development of more sophisticated satellites equipped with advanced processing capabilities, AI-driven data management, and improved encoding techniques. These innovations will enhance the efficiency of data transmission, reduce costs, and improve the overall performance of satellite internet services. 6. Diverse applications across industries. The demand for satellite internet services will extend beyond consumer applications. Industries such as agriculture, aviation, maritime, and disaster management will leverage satellite connectivity for real-time data collection, monitoring, and decision-making. The growth of the Internet of Things (IoT) will further propel the need for reliable satellite connectivity in remote locations. 7. Competition and market growth. While satellite internet services are expanding, competition with terrestrial broadband providers will intensify. Companies will need to differentiate their offerings through pricing strategies, service quality, and unique applications tailored to specific user needs. This competitive landscape will drive innovation and service improvements across the sector. 8. Environmental considerations. As satellite launches increase, environmental sustainability will become a crucial focus. Innovations aimed at minimizing space debris, such as deorbiting technologies and end-of-life management for satellites, will be essential in ensuring the long-term viability of satellite internet services and maintaining the orbital environment. 9. Investment and economic growth. The satellite internet sector will attract substantial investments as demand for global connectivity rises. This influx of capital will facilitate the development of new technologies, expansion of satellite networks, and the creation of innovative business models tailored to diverse user segments. 10. User-centric innovations. Future satellite internet services will prioritize user experience with advancements in user terminal designs that enhance mobility, versatility, and ease of use. As costs decrease and technology improves, more users will gain access to satellite internet, fostering a more connected global society. In conclusion, the future of satellite internet services holds immense potential, characterized by advancements in technology, increased global coverage, and a diverse range of applications. As the industry continues to evolve, the focus will be on improving connectivity, ensuring sustainability, and meeting the growing demands of users across various sectors. The interplay of innovation, regulation, and market dynamics will shape a robust and interconnected future for satellite communications.